In this video, we are going to learn index laws. You should already know what indices are. The index laws make solving complex problems much easier, and they are essential for understanding a lot of algebra processing. So there are 9 laws that we need to know to begin with. Number 1, multiplying terms with the same base. Number 2, dividing terms with the same base. Number 3, raising a term with a power to another power. Number 4, raising a product of terms to a power. Number 5, raising a quotient of terms to a power. Number 6, raised to the power of 0. Number 7, raised to a negative power. Number 8, raised to a power of -1. Number 9, raised to a power of -n. And they are quite logical to understand. Index law 1, when multiplying terms with the same base, add the power. So 2 to the power 3 times 2 to the power 4 is 2 to the power 3 plus 4, which is 2 to the power 7. In general is a to the power m times a to the power n, which is a to the power m plus n. Index law 2, when dividing terms with the same base, subtract the powers. So 2 to the power 9 divided by 2 to the power 4, or in fraction 2 to the power 9 over 2 to the power 4 is 2 to the power 9 minus 4, which is 2 to the power 5. In general, a to the power m divided by a to the power n, or a to the power m over a to the power n is a to the power m minus n. Index law 3, when raising a term with a power to another power, multiply the powers. For example, 2 to the power 9 to the power 4 is 2 to the power 9 times 4, which is 2 to the power 36. In general, a to the power m to the power n is a to the power m times n. Index law 4, when raising a product of terms to a power, raise each term to that power. For example, 2 to the power 9 times 3 in bracket to the power 4, they can be separated. So it's 2 to the power 9 to the power 4 times 3 to the power 4, which is 2 to the power 36 times 3 to the power 4. In general, AB in bracket to the power n, when separated, can be written as a to the power n, b to the power n. Index law 5, when raising a quotient of terms to a power, raise each term to that power. So, example, 2 over 3 in bracket to the power 4 can be separated 2 to the power 4 over 3 to the power 4. In general, is a over b in bracket to the power n is a to the power n over b to the power n. Index law 6, where any number raised to the power 0 is equal to 1, no matter what that number is. So 2 to the power 0 is power 0, so it's 1. If it's 2 over 3 in bracket to the power 0, no matter what's inside the bracket, if it's to the power 0, it's 1. So in general, a to the power 0 is equal to 1. Index law 7, a number raised to a negative power gives a fraction with a numerator of 1. So 2 to the power -3. So write a fraction with numerator 1 and write denominator with positive power, which is 2 to the power 3. We can also say that express the number with negative power as a number with positive power. So in general, a to the power -n is equal to 1 over a to the power n. Index law 8, a number raised to a power of -1 gives its reciprocal. So 2 to the power -1 is 1 over 2. So the 1 over 2 is the reciprocal of 2. So 2 over 3 in bracket to the power -1, take the reciprocal of what's inside the bracket, which is 3 over 2. So in general, we can write a to the power -1 is 1 over a, or a over b in bracket to the power -1 is b over a. So b over a is a reciprocal of a over b. Index law 9, a number raised to the power of -n gives its reciprocal raised to the power of n, similar to the previous law. So example, 2 over 3 to the power negative 4. So take the reciprocal of 2 over 3, which is 3 over 2, and then write with positive power, and then separate the power. So it's 3 to the power 4 over 2 to the power 4. In journal, we can write a over b in bracket to the power negative n is equal to, take the reciprocal of a over b, which is b over a, bracket to the power n, and then separate it. So b to the power n over a to the power n.